Hey, welcome to the channel. Today we have a 1987 Ford Ranger with no AC. You can see, there's, got the simple things. There's a belt on the compressor. Compressor is plugged in. Come around here to the interior of the vehicle. You see your AC button does in fact light up when you push it in. So you must have power going somewhere. What's going on? Come over here and look at your wiring diagram. You can see we've got light green and purple wire going to our AC pressure switch. So we probably first should make sure we got power here. And if your switch is working, you'll have power passing all the way through it. So you can see here, closes at 45 PSI. If your AC isn't charged up, the switch isn't going to close, power's not going to pass through. I just charged up the AC yesterday, so I know I have good pressure. As you can see here, we've got a multimeter. That's probably the most important tool of this job. You will need one of these to diagnose. Maybe just a test light, but I'm using a multimeter. Probing just this green wire, making sure we have voltage going into it. And as you can see here on the meter, we have 12 volts, 12.5 volts almost. So we have power coming out of our switch, out of the cab, over here to our pressure switch on the dryer. So then we'll plug it back in to confirm that the switch is in fact closed. I got a back probe here. Stick it in there. And there's almost 12 volts again. So we know our pressure switch is operational. Here at our diagram, you can see it has something very important notated. Normally closed. So what that means is when you push the button, current normally passes through here, going to your AC clutch, making the inside of your vehicle cold. You can see we have two wires here to the other side of the relay, the coil side, which will pull that leg away and open up the circuit, turning off your AC. This goes to EEC, which I believe is your engine computer. So if you have 12 volts coming into this relay from the small red wire, your AC is being commanded off by your engine computer. So here is a relay. This is the one original to the vehicle. Go ahead and observe your pins here. Look at the orientation of them. Then come over here. Look at the orientation of the pins on the plug. So you can see we're already off to a bad start. We have the two large pins are diagonal from each other versus here on the relay, they're right next to each other. So this relay currently is trying to plug into this unpopulated pin here. That won't work for very obvious reasons. So what I've done is I went ahead and tested the two small red wires. You can see I depinned this one because this is the 12 volts coming from your ECU or EEC, whatever you prefer to call it, which will command your AC off. So let's go ahead and test that, see how many volts we have coming from the EEC. Because remember, this is a normally closed circuit, so this should not have power if we want our AC to work. Currently, we have no power, so the AC should work. So before I had shot this video, when you put your probe here, there was 12 volts coming from the EEC, which was commanding the AC off. Right now, we have about 0.2 volts, which won't do anything to the coil in that relay, so it'll stay as a closed circuit. You test the other leg here. Yep, you got no power coming to it. So next, we're going to test the other legs of our relay. We got 12 volts there, no volts there, which is, again, pretty standard. We want the 12 volts here to pass over to this pin here to power on our compressor. So we want to have no volts here and 12 volts here for that relay to stay closed and turn on our compressor. I don't know exactly what the condition is of the vehicle to turn the compressor on and off. Currently, as you saw, We do not have 12 volts here. I just went and drove the vehicle. It could be because it's warmed up. I'm really not too sure. On older vehicles, I guess this one is pretty old, but you know, on things from decades previous, you had to turn off the AC yourself to go ahead and pass somebody because there was just 0 horsepower coming out of that motor. So this may very well do the same exact thing. The throttle isn't wide open right now, so the ECU is letting the AC turn on. So first things first, we have our relay. We know the pins are in the wrong location, and you can see that slot there should have a pin. It does not. Come over here to your fuel pump relay, same exact style relay. You go ahead and unplug it, same connector. Flip it up, and look at that. There's 5 pins. That's what you want your relay to look like. Make sure you have the correct relay, and then also make sure you also have a relay that is normally closed. Most relays are normally open. Go ahead and plug this back in. So we have fuel. Bend that back down out of the way. So if our relay is properly functioning and you have the right relay, you should have continuity between this pin here and this pin here. This pin should be moved over there, then we'd have the right relay. So let's go ahead and test it, see what kind of relay this is. Do we have continuity passing through it right now? Is it normally open or normally closed? Go ahead and take our meter. You can see probing both sides of it. Look over at our multimeter, unlimited resistance. So right now, this relay is open, which is not what we want. We want a normally closed relay. There should be some resistance there. So this relay, junk. This relay is also a little bit of an oddball relay. Your standard automotive relays are typically not this kind. They're usually normally open. This is something that most likely you'll have to special order from the parts store unless you're lucky enough to have a hub store local to you. So what we're going to do is just do the relay's job for it. You can see I have a jumper wire here, just 2 spade connectors crimped onto a short piece of 10 gauge wire. Gonna go ahead and plug it in here. Remember, that leg had no power. This leg does have power, so we're just transferring power from here to there. Pretty simple. So we're gonna go ahead and plug in our spade here. Little persuasion. Plug it in here. Listen to that. You hear that click? That's our AC compressor clutch engaging. Make sure that this is, all the way in there. If it's summertime when you're watching this right now, you're gonna want this plugged in. If it's wintertime, you should worry about your heat, not the AC. Set that down out of the way. Remember, you don't have to de-pin this. I just did for testing purposes. You can go ahead and put that back in the connector while you wait on your new relay that is properly pinned. So I'll just go ahead and take that. Heard it click, give it a little pull, make sure it's seated. Now your connector is reassembled for when you get your new relay. Come over here to your AC compressor. And you can't spin the clutch because it's engaged, which is what we want. So then we'll come over here to the interior of the vehicle. Remember, you want key on the whole time you're testing this. Just to confirm, AC is on, compressor is engaged. We're gonna turn our AC switch off, come back out here to the compressor, and it should spin freely. Look at that, now it spins freely. Back into the vehicle, turn your AC on, fire it up. Power jumper plugged back in. Compressor is engaged. You can see in here it's about 61 degrees on the floor. Yeah, 64 degrees. Come over here to our vehicle. That looks colder than 64 degrees to me. It should continue dropping in temperature the longer this thing runs. And you have now fixed the AC on your 87 Ford Ranger. Hope this was useful to somebody. Thanks for watching.